So in this video, I'm going to cover the system design question called Amazon Product Review System Design. So before we start the real content for today, I would really appreciate that if you can help subscribe to this channel because it can help this channel to grow. So thanks in advance. Let's get started. So in the real coding interview, in the real system design interview, usually you start with asking some questions, have a nice discussion with the interviewer to talk about the real feature request. Because the problem can be rather broad, we need to further clarify what are the specific feature requests we need to care about in this 45 minutes or 1 hour system design interview. And also we need to clarify the non-goals we are not going to cover here. So let's say so at the end of this part we will have the feature request defined here and we have the non-goals clarified. So let's say we are only going to cover the backend service part, so which means we are not going to cover the UI UX like the mobile design etc. So the first feature request I can think about is I need to clarify what is a comment like. So let's say we need to support the buyers to review or comment. So let's say in the review we will have the 5-star stuff and also the title and also description, and we are also going to enable the user to attach some images. So let's say we are only supporting the images. Videos, don't care about this, but usually image and video are pretty much the similar infrastructure which are going to be stored in the blob store somewhere. But let's say we only support images here. Let's say the next part I would ask is so I think for the comment or the review, it should be limited to the buyers who have already bought the product and also the product has been delivered. So let's say we are only going to support real buyers to review, and also the buyers can update the review and can update the review in the future. And also the next thing I want to think about is, do we support like the reply from the inventory owner, like the shop owner, and do we support like the reply on the reply? So let's say we support reply between the owner and the buyer. So that's pretty much it about this feature request part. Like for some non-goals, I think not too much to talk about here, but let's say videos, don't care about this. So having said that, let's start to do the next part, which is the constraints analysis. So usually in this part you're going to do some back of envelope calculation to understand the traffic, to the storage, availability, scalability, consistency, something like that. So let's say let's first do some traffic analysis. So for the traffic, let's say we are targeting the first 1 billion user, 1 billion daily active users, and each daily active user is going to give 1 comment, 1 review per day. And out of 10 reviews, there can be 1 images. So 1 image out of 1 image out of 10 reviews. So the traffic is 10 to the power of 9 per request per day, which is going to be happening in let's say 24 hours per day and 3,800 seconds per hour. So this one we are targeting about 10k for the QPS. So let's assume for the peak time we have 30k for the QPS. So this would be a pretty good estimation for the traffic. So the next part, let's say we need to do some storage analysis to see what is the total storage we are going to use for the next 10 years. And also, once we have the number, we will need to decide where we are going to store the data. Sometimes it is SQL, sometimes non-SQL, maybe sometimes it's just a file system. So let's say we are having 1 billion reviews per day. So let's say for the text part, so usually we store the text in the database, and we store the images in blob store, or so underlying the blob store, it is the file system. So image, so it's 10 to the power of 9, 1 billion reviews. Let's say for each of the review it is going to take 5k, or let's say it is 5k per review, and we are going to target the next 10 years, so which means next 10 years is 3. So this is how many reviews. Each review is like this size, like for the next 10 years. So what is the total size of this one? So this one, it is like 8 gigabytes. So this is gigabytes. This is 5 TB. This means times this, it means 5 TB. So 5 TB, 50 TB, 50 TB times 300, it is about 15 PB. Okay, so it's about 15 PB. Yeah, so yeah, it's about 15 PB for all the data in the next 10 years. So for the images, it is similar calculation. So let's say this one, 5k times 10 times 355. So let's say each one is going to take about 1 megabytes of the picture. Let's say it is one image, one picture out of the 10 reviews, which means we need to divide it by 10. So this means we are targeting about so this is 15, so this is 33 PB for the total images. That is because we times 2 for this one on top of this, times 2 on top of this, and then divided by 10, so which is like 3 PB. Okay, so we are targeting 3 PB for the images and 15 PB for the text. So let's start to define some other SLOs for this service. Let's say we need to have this thing highly scalable, and also scalable, and also we need to have this service to be highly available. Let's say the availability is 99.99, which means a few seconds downtime for each of the year, or maybe a couple hours. I don't remember the exact number. So availability, scalability. Let's say a high availability means we are going to not be able to have the strong consistency. Let's say this one we are going to have eventual consistency. So availability, scalability, consistency, maybe durability, to make sure that we don't lose data, to try to avoid any single point of failure. So that's mostly about this part. The next part is about some design overview. So the design overview, you will need to design the general architecture about the service, and define the different components you're going to have, and the traffic between the different components. So usually, so let's start from the users to analyze the data flow. So usually the user is going to send some HTTP request to our service. So first of all, it is going to hit our load balancer, then it is going to send some request to the web server, or app server, or front-end server. Let's say it is just front-end server. And then the front-end server is going to send the RPC request to the back-end server. And usually there should also be a load balancer in front, in the middle. So the backend server is going to try to do some data manipulation, like query the DB, like update the corresponding array, etc. So if it is a query, usually there is a cache layer sitting on top of it. But for DB, and if it is update, we are going to write to the DB. So for the DB, we usually have some master slave set up to make sure that we have the redundancy, to make sure that we don't have any single point of failure here on the DB part. And also for the cache layer, we try to use distributed cache here. So this is a very high level, very high level architecture design. So let's see what are the components we are going to have to support the different features. So the first feature, it says that we are going to support the buyer to review or to comment. So of course we are going to have the comment service here. And the next part, it says that we need to support the real buyer to review and can update in the future. So it means that we should have like an other verification service here, which means we are going to verify if the for the corresponding user who sent the request, if he has bought this product before and the product has really been delivered, and also it is based on like the other information we get. And the next one is like the reply between owner and the buyer. So it is, we can also include this in the common service, just different APIs. So let's say currently we have two different services, and so for the other service, what is the request like? So for the other service, the request is something like we need to send the so of course we need to send the other ID of this, and yeah, so let's say suppose we just send the other ID. I think it's pretty enough for us to validate. Yeah, I think it's pretty enough for us to validate this. So we are going to include the other ID in the request, and for the response, we will have like the status, which means so for the response, we need to return. So we could return the status, which the status means whether we can, and whether this other is verified or not. So like, or maybe it is a Boolean trying to differentiate whether the buyer has bought this product and also it has been delivered to the user. But it depends. So we can use a status here, like it is a enum, something like that. So that's the other verification part. So let's see the next one. So the next one is common services, which is a major part. So the common services, first it is going to call the other verification service, send the other ID to the service, and get a response. So if the response is positive, indicating that the other is verified, then we can further do some DB updating so that we can update the DB for the comment. So for the common service, we need to first of all, it is a common API, and also we will have the reply API, and also we need to have like the show API or display API. So the display API is going to essentially display all the comments or the top comments for the product. So let's see, for the common API, what is the request like? So for the request, we are going to include comments. So we are going to include the product ID. We are going to include the customer ID, and we are going to include the other ID, and also we are going to include like the star information like the title, description, and if there's any images, we need to also include that. So this image, but this image is just the pass within our file system. So those are the things to be included in the request. And what is the response here? So the response is like a status code to see whether the request is successful. So this is pretty much about the request for common API, and then the reply API. So what is that? So we need to so before the reply API, we actually need to design what is the comment, the proto for the comment. So let's say we have the message defined as the comment, and let's say we have like a message defined for the reply, or we can simply reuse that. So for the comment API, what we are going to do is we need to have the product ID. This is the product ID, and the customer ID, and also we need to have the other ID. We also have the star information, say, and we have the title, which is a string. We have the description, and we have the repeated of the images. So those of the stuff are going to be defined as optional, but this one is going to be defined as repeat. And for the after that, we need to have the reply, which is also a repeated field, like the reply. So for the reply, what we are going to do is we need to have the ID of the reply. We need to have the ID, and suppose we just support the text-based reply. So we are going to have maybe just the string, simply the string of the message. So each of the reply can also have a couple of the replies. So you have a repeated field of the replies. So this is pretty much how we define the messages for the reply. So based on the message, we are going. So how are we going to design the request and the response for the API, request API? So you're going to have the request here. So the request is going to be essentially including the. So it is going to include the product. I would say it is the product ID and the customer ID, and also maybe not so maybe not the other ID, but actually we should have a comment ID for it. So the request should include the, let's say it is going to include the comment ID, and the reply can be a reply of another reply. So we could include a pass, so which is a repeated pass. So this is the pass to the reply. So if this is something empty, then it is the direct comment, direct reply on the comment. If it contains something, then it is some reply, the reply of some reply. So we are going to go to the corresponding pass, and then update the corresponding reply there. And the response, of course, it is going to be some status codes here to show it is successful or not. And then the display API, we are going to request and the response. So for the request, of course, it is going to include the product ID, and it doesn't need to include the customer ID. So it is list the first several comments or first several review for the product for future buyers. So it's something like so let's see. So let's say this is count, like how many of the reviews are we going to return, and also like maybe some time range, timestamp, start time, and the time, etc. So this really depends on the filter we are going to set, but we have this, let's say we have those kind of filters, like how many of the reviews are going to return for the maximum, the start and end time, something like that, and the reply is going to be a list of the comments. So that's pretty much it about the API design, general overview, although it includes some kind of the details here, but okay, so let's go through this the data flow again to see how it works. So for the comment service, let's say I'm just a buyer and I have already bought my I bought my stuff, got it delivered to me, and I have happy experience, and I want to write some comment. So first of all, I'm going to initiate a request. So to include like the product ID, the customer ID, other ID, etc. And all the titles, description, images. I'm going to do that, include all of that. So first of all, when it hit our backend server, we are going to first call the verification service to verify this order, to make sure that this order is the real order, and we are able to make some comments on the product. And then we are going to call our common API to send the request, and then to send the request, and then update our database, and then the response. And then for the reply API is something very similar, but we also need to do some verification here, because we need to make sure that I am the customer who actually made the comment, who made the original comment, or I'm the product owner of this product. So we still need to do some verification. But so how to do? Okay, so I think we need to have another API to verify that we can actually make the reply actually on this common ID. So when we send the product, so we send along the product ID, customer ID, and the common ID. So based on the common ID, we need to make sure that the customer that it is a customer actually. We have, it is me that have already made the comment before, or it is a product owner. So maybe for the product owner side, there is another different version of the UI. Let's don't care about that. Let's just focus on the customer part. We need to make sure that when I reply, it is me who made the original comment. So that's it is based on the common ID and also the customer ID. So for the display API, we are just going to pull the comments based on the filter we set up, and then return the comments as a proto buffer, and then send back to the front-end server, and the front-end server is going to further wrap up as a JSON message to be returned to the user. So that's general workflow about the thing. So that the next part is about to do some detailed design. And so for me, so I usually don't really want to design some toy system and then try to scale. So instead, what I usually do is, when I collect the numbers, I understand what is the system I'm trying to design. So I'm going to try to make it scalable enough at the very beginning, because if we try to come up with a toy system and then we do the scalability enhancement in the detailed design part, that might be not really good, because we did the generating free structure design. If we confirm the generating free structure and it is not scalable enough, we may need to end up with changing the generating free structure when we think about the scalability in the detailed design. So usually I would suggest you to think about the scalability when you do the general infrastructure design in the last part. So let's say the detail design. So the detail design, let's start with the database. So in this part, usually the interviewer will lead you to design something, to see different components, how to design the different components, how you deal with the scalability issue, the availability, etc., consistency, etc. And it's very common for the interviewer to dive into DB part. Let's say for the DB, we have several things to store here, but we don't really need to care about like the user profile, etc. Like we don't need to care about the merchant inventory, etc. Instead, we just need to care about the product and the corresponding comment. How we are going to store that. So let's say for the DB, we actually have two parts. One is the image, which is going to be stored in the blob store. This part is pretty straightforward, and we are not going to talk about that. And then the next thing is blob store. Underlying the blob store, there's usually the file system. So the next part is the comment or the review. How are we going to store that? So based on the data volume, we usually need to use non-SQL. So for this kind of data scale, because for SQL it is quite hard to scale when there is a larger volume of data, because indexing is not going to help too much here, and also the sharding is going to be very complex. So for non-SQL, it is very natural to have a high scalability. So let's say, so first of all, let's confirm which kind of non-SQL we are going to use. Let's say we are going to use big table here. So for the big table, which table are we trying to define or design? So let's say we have the product table, of course. So I'm trying to think whether we need to include whether we need to try to include everything like the real comment material in the table. So I think that's a good thing to understand. So let's say if we have the product and comment stored in the same big table together, once there is a lot of the comments, I think it's not going to be too much of a big deal. But let's say we are going to store the comment and the product separately. So for the product, the row key, of course, is going to be the product ID. And also we have the columns. So the column family, we should include the basic product info, like some descriptions, like some picture, the address to the path to the pictures, etc. And also we have another column family. Let's call it the comment. So for the comment, the column family is like this. And what are we going to store for here? So for each of the, so let's say I'm trying to think if we are going to have a different column for each of the comment, or we are going to have like everything to be in the default column. So let's say if we have everything in the default column, yeah, so I think that's, yeah. So for the comment, we are going to, so this one we are just going to ignore this. So for the comment, we are just going to use the default column, which is something like comment, like this. So you're going to store the comment in this default column. So in a big table cell, it is something like, so the row key as a product ID, and the comment is the comment is the column is comment default column, and you have this timestamp, and also we have the and we have, okay, so if we have the, so the thing is, we have, if we have if we just use a default column, what if there are two comments that happen at a exact timestamp? So that could be something problematic here. So okay, so let's say we are going to have the comment and the comment ID here. Store this one, and then actually we don't need to store anything in the real value. We just leave it empty here. Okay, so yeah, I think that's pretty much it about this the product table. And the next thing I'm trying to have is the comment thing. So for the comment, of course, it is going to be the comment ID, and then the comment ID, by the way, it is a globally unique ID. So we could set up a component which is to generate the unique ID. So we have talked about this, which is, so that's based on the timestamp, the data center ID, the server ID, and also some rest of the bits to do for deduping. So let's say you already have a component which is to generate the unique ID here, and we have the column family. So that one is mostly about this. Let's say this is a comment. So we only have. So we are going to just use the default column here. So here you have the row key as ID, and the comment is going to be the default column, and this is a timestamp, and also we are going to store a proto buffer which is defined here. This message. This says comment message, so we are going to store the comment proto buff. Comment proto. This is a serialized proto we are going to store here. So let's see the data flow. So first of all, we are going. So when we call the comment API, we are going to generate the comment ID. Call the unique ID service to generate the comment ID, and then we are going to store the real comment into the comment table, and then store and also update the product table to include the new comment. So I think that's pretty much it. So if you worry about like the scalability, so you don't need to worry about the scalability actually, because Bigtable is highly scalable. It's a NoSQL, very highly scalable. And for this one, you need to set up some master-slave replication to make sure that you don't introduce any single point of failure. So you need to make sure that there is enough duplication, enough redundancy about the data, and also because we have the master-slave stuff, when users try to query the display API, we can also try to find the corresponding slave that is nearest to the user, and we are going to return the data there. But of course, there's going to be a cache layer sitting on top of that. Let's say this is the DB design, which is pretty much it. And also the reply API, I think that's quite simple. So we just define okay, so we mentioned that we need to do some verification here. Okay, so if we need to do some verification here, so what we need to do is we also need to store something else, which is let's say we have another column, which is the basic info. So in the basic info, you're going to store the product ID, the customer ID, and also the merchant ID in this info, so that when we try to call the reply API, we can first we are going to first validate whether whether we are able to reply, whether we are authenticated to reply, and then we try to update the comment proto. And then the display API. So the display API, first it is going to. So first we have the product ID, and then we get the corresponding row. And usually usually we have a cache layer which is already storing the product ID if it is a very popular one. Otherwise, we are going to get the corresponding product and get all the comments from the big table. But usually, if it is a very popular product, we should already have that in the cache. And based on the comment ID, we are going to query the big table, and usually we have a cache layer to cache the comments. So we get all the comment IDs, and then we get the real comments where cache. If cache missed, then we get the real comment from the database. And then combine all of them together, and then return to the user to show the real comments. And actually, we need to have a comment service here, which is the comment service is going to. So the comment service is going to. Well, since we already have the display API, we can. Yeah, so we already have the display API. So I'm thinking whether we need to actually set a different service, which is like send the request, including the comment ID and the replay, and then return the comments. But it really depends on the granularity. Like for here, we just define API on a higher granularity, which include all the logic, all the business logic. But if it is too difficult or too complex, then what we could do is we could define the different APIs and then call the different APIs to do like to make sure that each of the API can do just a small part of the work. So I think that's pretty much it for this question. What else? I'm trying to see what else I'm still missing. So we are already supporting the comment, the reply, and also the verification stuff. And it depends on where the interviewer is driving us to. So let's say maybe sometimes people ask about the cache. What kind of cache are we going to use? Let's say usually we just use map cache D for this. And let's say, and because you use cache, and we should be able to fix the issue, which is the hot sharding issue. So because each of the shard or each of the tablet can be very for the big table can be quite hot. Or can be quite popular if we have the cache, which is going to significantly reduce the workload on the DB if there is a lot of the query on top of a popular product for the comments. So I would say not too much to talk about here. So I think that's pretty much it about this interview question. So if you like this video, please help subscribe this channel. If you have any question, feel free to leave some comments below. I'll see you next time. Thanks for watching.